Welcome to our review on acceleration and velocity. So first thing we actually need to do here then is understand what we mean by the term acceleration. Now basically when we've got an object and its speed is changing, then we have an acceleration. Now the thing to bear in mind is it doesn't have to be speeding up, it can be slowing down for it to be this acceleration, because acceleration can be either positive or negative. Okay, so do go careful that when talking about acceleration, we're not just talking about things that are increasing in speed. They can also be decreasing in speed and therefore demonstrating what's known as negative acceleration, or what we refer to more frequently as deceleration. The equation we actually need then to calculate our acceleration is again found on page 2 of your exam booklets. But so we understand it, we'll go through it now. Acceleration, which has the units of meters per second squared, equals the change in speed divided by the time taken for the change. Now first thing to notice there is it is the change in speed. Okay, so don't just look at the final speed, it's the difference between the speed the object starts at and the speed it finishes at. Okay, so to give you an example of the kind of question you might get there, the speed of a train increases from 15 meters per second to 35 meters per second in 10 seconds. What is the acceleration of the train? So all we need to do there is first of all work out our change in speed. So that's going to be 35 minus 15, which gives us 20 meters per second, and then we divide that by our time, which is 10 seconds. So 20 divided by 10 gives us the acceleration of 2 meters per second squared. Now we've got a second term associated here, which is velocity. So what we need to do now is understand the difference between an object's speed and an object's velocity. If we're talking about the speed, quite simply what that tells us is how fast it's going. Okay, that's it, just how fast it's going. If we're talking about the velocity of an object, then it tells us how fast it's going and in what direction. So as opposed to just a speed of 50 miles per hour, then the velocity would be 50 miles per hour north. Okay, now what we've got on that little diagram of our two cars then is something that shows us the velocities of two different vehicles. So we've got our red car travelling in one direction and our blue car travelling in the opposite direction. Now they're both travelling at 40 miles per hour, but when we're then going to convert this into a velocity, we can say that the red car has a velocity of plus 40 miles per hour, and because our blue car is travelling in exactly the opposite direction, then we can say that the blue car has a velocity of minus 40 miles per hour. The last thing we need to understand then is something called the relative velocity. Now this is something you may well have noticed in your everyday life when you've been sitting in a car on the motorway. Anything that's overtaking you going the same direction seems to do so really quite slowly, whereas anything going in the opposite direction to you seems to whiz past really fast. So this is all down to this thing called relative velocity. In the picture at the top there, what we can see is we've got a train and two cars. So our train is travelling at plus 80 miles per hour, okay, so it's got a velocity of plus 80. And the black car there is travelling in the same direction as the train with a velocity of plus 70 miles per hour. The yellow car, which is travelling in the opposite direction to both, has a velocity then of minus 70 miles per hour. So if you imagine you're sitting in that black car and looking out at the train, it's going to look like it's only moving past you at 10 miles per hour. And the way that we work that out is we start off with the velocity of our train, which is plus 80, and we subtract the velocity of our car that we're travelling in. Okay, so that would be 80 minus 70 gives us the relative velocity then of 10 miles per hour. If we were sitting in the yellow car looking at that same train, what we'd actually see is that the train seems to be going past really fast. So by doing that same calculation, so 80 is our train, and then we've got to still subtract the velocity of our car. So we're actually going to be taking away minus 70. Now 2 minuses makes a plus. So in reality the calculation we do is 80 plus 70, which gives us our relative velocity there of 150.